more efficient. Traditionally, parachain on Polkadot had a block time of 12 seconds, and with async backing, this is reduced to only 6 seconds. So this means parachain can produce block more often, and the network as a whole can handle twice as many transactions as before. And instead of building and inspecting every product in 6 seconds flat, product can be built in parallel and inspected asynchronously, same safety and more output. That's the analogy that you can think of async backing from the factory perspective. So in the over next 20 minutes, we will work through why async backing is needed, how block production worked before async backing, and also how what changes async backing introduced, the impact on scalability, latency, and also the throughput, and finally why this matter for builders and also the user of Polkadot. And by the end of this section, you will have a clear picture of why async backing is cornerstone of Polkadot 2.0. Now we have a slide here. We go to the problem page. The problem before we have async backing. We have asynchronous bottleneck. This is also the reason why async backing is important. Why the 6-second windows created the limitations for parachain before. So imagine every parachain having to build, validate, and submit their block in the same 6-second window. If they are late, their block get dropped and wasted effort. And to dive deep a bit on this system, there's a section that we have in the bootcamp called understanding the parachain block and also understanding the architecture of Polkadot. And to be more details, so the parachain create the candidate blocks that need to be validated by the Polkadot relay change. Because all the parachains share with the same security hoop called the relay change. In the old model, parachain had 12 seconds to both build their block and also get it validated by the relay chain validators. So this means that block builders had a limited time to produce their block. Validators had to check the block in the same windows. And also blocks get dropped, wasting computational resources. And parachain throughput artificially capped by the timing. And that's the limitation of the synchronous model. And the downside was very clear. So latency was high, throughput was limited, and also the whole system wasn't using its resources efficiently. Of blockchain, we have security, scalability, and also decentralizations. Polkadot already fulfill the two attributes, security and also the decentralization with the old model. But with this new model, we can also reach to the scalability side and complete solve all the attribute that we need for the dilemma. And here we also have some statistic for the before async backing architecture. So we have the relation block time is around 6 seconds. Parachain build windows is 6 seconds. Validation time same as 6 seconds. And block drop if late, yes, and throughput potential is limited. Now we go to the solution slide where we introduce async backing. So what does async backing change? The key idea is that block production and block validation are now decoupled. That means the two-stage block production and block validation is no longer tightly coupling to each other, and these can happen in parallel. So instead of forcing the parachain and validator to do everything within a single slot, async backing let parachain work asynchronously with a relay change. And here's how it works step by step. A parachain builds a block candidate and submit it. Validators can validate the block in parallel while the parachain is already working on its next block. If validation takes longer, it no longer blocks the parachain from progressing. And this asynchronous process has two huge benefits. So first, it allows the parachain to produce blocks every 6 seconds instead of 12. Because now the two stages happen at the same time, similar to the CPU pipeline. When you have one instruction is being executed, the another instruction is already being decoded and processed. And second, it keeps the pipeline full. So the pipeline don't have to be idle, and it can maximize the efficiency of the pipeline to process multiple parachain blocks at the same time. So parachain don't have to sit idle waiting for validation before starting on the next block. And to understand it in a better way, if you're interested, you can visit the documentations pipelining, and in the pipelining documentation, you can find the technique that Polkadot is using here. It's quite similar to the CPU it's similar to like the CPU, and if you scroll down, it's gonna like describe the asynchronous backing, and you see like before, the parachain block is need to get to two stage the backing and inclusions, to be like, added to the global history of the relation, and only like, after the inclusions the backing gonna happen for the next block. So in that way, like it only requires at least like 12 seconds for the block to be included to the relay change. But like with async backings, everything can happen in parallel. So while like, the inclusions of the past parachain block is already running, the backing process of the next block is already happen at the same time in parallel with the inclusions of the stage 1. So let's imagine this is like stage 1, stage 2, stage 3, and also the stage 4. When the inclusion stage 1 happen, the backing stage of the stage 2 is already happening at the same time with the inclusion stage 1. And that's how the asynchronous backing is gonna can help to reduce a lot of time to get the block validations. And there's also some comparisons here with synchronous backing and asynchronous backing that you can read more to understand like how asynchronous backing work under the hood, and also like more details about asynchronous backing. But due to like the time limit of the course, we only like cover some key features of asynchronous backing. And with that in mind, as you can see, like the old asynchronous process, everything happened in the same 6-second windows, rush to build and validate simultaneously. Late block get dropped, throughput bottleneck. With the new asynchronous backing, the block building happened asynchronously. Up to like 2 relay chain blocks to submit, validators have breathing room, 3 times throughput improvement and higher efficiency. The old model is wasted resources. So the pipeline process is going to be like build phase. The collator repairs the block candidate asynchronously, no rush. The backing phase, validator check candidate and sign approval with adequate time. And inclusion, like the candidate included in relay chain was properly backed. And that's how the asynchronous backing solutions works under the hood. Now we move to the technical deep dive. Now let's dive a bit deeper into the technical detail of asynchronous backing. So in Polkadot architecture, the parachain produce blocks that are checked by validators on the relay change. The validators create the backing vote to prove the block is valid. And with asynchronous backing, the time available for block validations is extended. So validators don't have to complete the validation within the same slot. Parachain can continue producing blocks without waiting for the relay chain approval. Block can be validated across like multiple relay chain blocks, giving the validators more flexibility. This is possible because like Polkadot separate the concern of like building a block and also like checking a block validity. So by decoupling the process, asynchronous backing achieve both faster productions and safer validations. And key technical improvement we have here, like parachain can repair multiple candidates in advance, creating a pipeline of block ready for validations. So smoother block productions, better resource utilizations. For workload distributions, validator workload is spread out over time instead of concentrated in 6-second bursts. So more time for cryptographic check and also increase relation efficiency. And with that in mind, we also have some performance number. The throughput is increased like 3 times, and the relation block times also like reduced to only like 6 seconds. How about the reward benefits? So why does it matter? So first, it's double the throughput for the parachain. Going to like 12-second blocks to 6-second blocks mean like parachain can handle twice as many transactions. Second, like it reduces the latency, and transactions get included faster because like blocks are produced more frequently. Third is set the stage for future scalability upgrade. Async backing is just the beginning. Polkadot will continue optimizing like how parachain use relations resources. This means cheaper, quicker, and also like smoother transactions. And for the ecosystem as a whole, it means like Polkadot can scale without like sacrificing security or decentralization. And also some reward benefit we have here. The developer can build more complex transactions, more time to build a sophisticated block. less risk of skip block due to timing, faster confirmations, and smoother apps. For the validators, the workload distribution, as we mentioned, validations spread over time, so validators gonna have more time to validate the block, more time for cryptographic verifications, and also better relation resources utilizations. And for the end user, consumer user, more consistent parachain app performance, because now we have like more throughput, lower latency in transaction processing, and also cheaper fees due to higher network capacity. And network roll like 3 times parachain throughput and enable more complex applications. Okay, so let's recap on like what we learned today. Asynchronous Backing is a Polkadot 2.0 upgrade that reduces the parachain block time from 10 seconds to 6 seconds, and it achieved by decoupling the block production from validations and allowing them to happen asynchronously. Parachain can now like pipeline multiple blocks, keeping the system busy and efficient, and the result is higher throughput, lower latency, and improved scalability. And right now, like the Asynchronous Backing is already like on Kusama, so you can like deploy application on Kusama, see like how fast the block include see how new block is produced and included to the change. The Polkadot rollout like gradual deployment to mainnet, and also like continuous optimizations, ongoing improvement to throughput. So what does that mean? The foundation for elastic scaling is ready. Parachain can be more complex application and network capacity significantly increased, and better user experience across on-chain. And that's how the Asynchronous Backing set the foundation for the Polkadot 2.0. And see you in the next video to learn more about Azure core times and also like more topic related to the Polkadot 2.0. Thank you.